So, right, um, let's get cracking then. So, what I'm going to talk about is essentially what I've been working on the last few years, and what I'd really like to get more and more people involved in. So Idris 2 is my pet language. This is my take on functional programming with dependent types. I'm having lots of fun with it. I'm particularly having a lot of fun with Idris 2 now, because finally I get to use Idris for a project that I care about. That is Idris itself. So if you make a programming language, then you kind of want to do something worthwhile with it. Turns out all I really know how to do is implement programming languages. So I thought, hey, let's see if we can implement Idris in itself. So that's what we're going to talk about. So what is Idris? I'm kind of assuming that I'm kind of assuming things about the audience here. So I'm generally assuming that a lot of you will be grad students. Some of you will be maybe industrial developers who are looking to learn a little bit more about what's going on in language design in academia at the moment. But just as I was going to say show of hands, just as a ping of hands, has anyone done much Idris programming? So if you've done a little bit, please. I'm just going to try to judge how much pinging is happening. Okay. Over time I'll get an impression of how many pings is a lot and how many pings is not many. This sounds like a lot of pings. Okay, so there are quite a few people who've done a bit of Idris programming. So I'm going to tell you a bit about the internals of Idris. I'm going to show you a little bit about how it works, a little bit about how you might contribute to it in the end, and in some ways this is about teaching you to be able to contribute, but in a lot of ways it's just about kind of advanced programming with dependent types. So learning a few techniques that you might not know about, and maybe going off to work on your own systems. I know a lot of you will be doing your own experiments in programming language design. Yeah, so a lot of you will be doing your own experiments in language design, and hopefully this will give you some ideas about how you might go about doing those bits of implementation. So I'm going to do a brief introduction to Idris, or at least the bits of Idris that are going to be important for implementing Idris. So some of the things I found most useful. And we're going to spend most of the time implementing a little language that, for the want of a better name, I've chosen to call Tiny Idris, which is a scaled down version of Idris that just has the important core features. So it doesn't have much useful high-level syntax. It does have type checking, it does have evaluation, and a little bit of unification. When I say it's scaled down, it's maybe cut down. So what I mean is I literally did take the full Idris 2 and I took the core and chopped out the bits that were not going to be important. I've even tried to add an extra comment or two here and there. So what that does mean is that if you found your way around Tiny Idris, if you're able to implement some of the features, then there is a direct mapping to what's going on in the real system. So if you can figure out what's going on there, you'll work out what's going on in Idris itself. So one other thing, if you didn't see on the Slack, I'm putting the materials for this course up on GitHub. So all of the code that I'm going to work through is up there, and these slides are on GitHub. So I'll put the slides up in advance. I see no reason to keep the things in the slides a secret. So if you do want to look at the slides ahead of the lectures, then that is something you can do. Just as advance warning, don't expect the slides too far in advance of the lectures, because it's possible I won't have prepared them too far in advance of the lectures. But they will be up there in advance. Right, so what we're going to do, you will hopefully, by the end of this, my goal for you is that you will have some understanding of the essence of dependently typed languages, so how they work. So the primary things that you need to implement in order to have a dependently typed language working. So I'll show you type checking, show you how type checking works. I'll show you how elaboration works. So the distinction between type checking and elaboration, by the way, at least as I look at it, type checking is where you have, so in the Idris sense at least, is you have the core representation. It's completely explicit, and we will check that the completely explicit core representation is well typed by the type that you've claimed that it has. Elaboration is a higher level step. So it's where you take something that is more like what a human would write, more like the user level code, and, as it were, elaborate it, embellish it. So put all of the concrete, precise type information that is needed in order for the machine to type check it. So what Idris 2 does is it'll take your high level Idris program, go through a few steps of elaboration. It will eventually end up at the core representation, and at that point we have a very small core language. It is then possible to feed that again to a type checker that's just not very clever at all, and it just knows about the core typing rules, and it can ensure that what is produced as a process of elaboration is valid. So it's an additional validation step on the result of elaboration. So the distinction between elaboration and type checking: elaboration fills in all of the details that you have left implicit. Type checking is checking the completely explicit representation. So you'll understand how the core representation works. And I'm going to spend quite a lot of time on the core representation, basically because if you understand the core representation, everything else is, I'm not going to say plain sailing, but it's everything follows from the core representation. And in fact, if there's one thing I've learned about dependently typed programming from this process of implementing Idris in itself, is that you don't actually need to use dependent types an awful lot. You don't need a lot of dependent types in your system to get a huge amount of benefit. So I spent, when first working on Idris 2, I spent an awful lot of time just working out what the core representation should be, kind of trying more things in the type versus less things in the type. So if I have too many things in the type, the machine starts to get in the way. If I don't have enough in the type, then the machine isn't helpful enough. So I spent quite a long time figuring out what that representation was to get the right amount of help from the machine without the machine getting in the way. And we'll see a little bit of the story of how I got there and what we ended up with here. So, but everything has followed from that. A lot of the decisions I've had to make later on have been following on from what the core representation is. So you'll learn how to implement some of the useful components of a complete dependently typed language. It will be a small dependently typed language, so it won't be something that you would expect to be able to use for day-to-day work, but it's something that that you could use as the basis of your own projects. And in fact, so a lot of you will be grad students, I'm assuming, or I've seen from the list of people who are here. And tell you something that basically how my PhD went was, sitting at my desk, not really knowing what was going on, not really understanding very much, and Colin McBride and James McKenna basically sitting me down in front of a blank Haskell buffer and making me write a tiny type checker for a dependently typed language. And as soon as I had that, it was like, well, this is too hard to use. How do I make it easier to use? So how do I implement tactics on top of that to turn it into a bigger and more useful language that I can actually do some research around? So one of my goals here is to get you to a place where you could be able to do the same thing as I did, taking a complete but small language, taking some aspect of language design or dependently type programming that you happen to be interested in. Let's say, hypothetically, you're interested in type-driven program synthesis, so I picked that because that's what I'm interested in at the moment. You can do a lot better, or you'll have a lot more success, I think, in the short term, working with a very small core language, the like of which we're going to work with over the next few days, than if you try to do it in the context of the full Idris system or the full Angular system or Coq or whatever system that you happen to pick. So you can use this as the of your own project. I'm totally happy for you to do that. Steal my code, do something interesting with it. And of course, the real reason is that I need help on Idris too. So the more you know about how the core works, the more I can get other people, more we can have other people than me dealing with some of the issues that come up with the core and contributing to the system. So I put a link on this slide. As I've been writing it, I've written some kind of sketchy notes, just outlining some of the decisions I've made, how some of the higher level features work. So by the end of this course, you'll be able to read that document and it will be able to teach you the bits that I haven't been able to cover here. Now, there is a lot of Idris too. I can't promise to cover all of it because we only have 4 lectures. So just in case some of these things are things that you were hoping for me to talk about, these are the things I'm not going to talk about. So I'm not going to talk about how quantities are implemented. I won't talk about how some of the higher level features get translated down to like the really high level features like case blocks and with expressions and where clauses. We're just going to look at the core features. I'm not going to talk about parsing for 2 reasons. Firstly, I've written here it's completely conventional. So there's nothing really new about parsing in Idris that you haven't learned from elsewhere. Not only that. Parsing in Idris is actually one of the bottlenecks in performance, which is a little bit embarrassing given that parsing is something that should be well understood. So we're not going to talk about that. I'm not going to talk about code generation because I don't like using the word straightforward, but it is relatively straightforward compared to everything else we'll be doing. And again, fairly conventional. Well, it doesn't mean I don't want to talk about them. I'm quite happy to talk about them. So please do ask me about other things, especially after you've learned a little bit about the core and you're thinking, how does some feature fit in? Please do ask me about them. Good times to ask would be, I guess we could chat informally over the over video after the lectures. We could chat on the SPLV Slack, and we can talk in various other places. But I'm going to claim that once you understand the core, these other features are easier to pick up.
Do we have a question?
Marvelous. Well, I'm just about to suggest a question protocol, but what do we have? Yeah, I have to scroll up a bit, so please just read. If you could read out the question, because I can't see it.
Do you want to unmute yourself?
I have no idea which question you're referring to. So.
Okay, so the question is, where should we look up ways to do case? Because it's less obvious.
Right. Case is a very interesting example, and I think I could do an entire lecture or more on case. I'm going to say ask me afterwards, because that's probably the answer to the question, quite honestly. Case is really quite tricky because dependent case is already tricky, and then you start adding quantities and things get trickier still. So yeah, I'm going to brush that question off slightly, I'm afraid. But please do ask me afterwards. One thing I suggest for asking questions, I'm seeing lots of things go by and I'm not really noticing questions. So I suggest what you do is ask in the chats, and if there is something I've missed, probably OHAD will need to prod me. So don't worry about appearing. Normally when it's an in-person thing, I normally suggest that if you have a question and you're worried that it's a silly question, just nudge the person next to you and say, do you understand what Edwin's on about? You don't quite have a person next to you at the minute, but please ask in the chat, and I'm not going to read out any names. If I do, maybe I hope I don't read out any names by accident anyway. So don't worry about appearing on the recording. But also ask questions not just in the lecture but outside the lecture. What I'll try to do is any questions that I've missed during the lecture, I'll try to summarize them at the beginning of the next lecture, particularly if there's a few things coming up quite often. But probably the right thing to do is ask in the chat, and I will wait for OHAD to prod me. unless I figure out a way of setting up what's in my line of sight, I'm not quite sure how I'm going to catch the questions, I'm afraid. Right, so today we'll have an Idris overview. I'll talk about the core features. I'll show you Tiny Idris. I've got some warm-up exercises, so I'm not going to have you just sitting there listening to me rabbiting on. I've got some exercises for you to try out. Today, they're just designed to get you doing a little bit of Idris programming if you're a bit rusty on it, and they are things that will come up inside the system itself. So even if you think you know how to do them anyway. If you do know how to do them, you'll get through them relatively quickly. If you don't know how to do them, you'll have learned something. So everyone's a winner. Tomorrow I'm going to talk more about the core language. So today I'm going to overview the system, just a kind of bird's eye view of what's going to happen. Tomorrow we'll get into the core language. We'll learn the most important thing, which I think if you've been following the summer school throughout, you'll have learned a lot about this already. So how to deal with variable names. So you'll already know that is hard. You'll know why it's hard, and you'll know about how to deal with it. So I'll show you Idris's take on it. And this is the Idris 2 implementation's take on it. And this is the place where we really use dependent types the most of all in the Idris implementation, is dealing with variable names. So guaranteed, the implementation of Idris will not have ill-scoped programs, because that's the one thing that we care about in the term representation. So we'll do a few manipulations on that. We'll do some of the important things that you'll need to be able to do to write any kind of operations on it. So weakening, contraction, substitution. So these things come up over and over again. Then we'll get to type checking and evaluation. So I've put these two things together because it's a bit of an awkward chicken and egg problem in a dependently typed language. In that, if you look at the typing rules, you'll see that the typing rules depend to some extent on evaluation, and you can't evaluate something that hasn't been type checked. So we'll see how these things fit together. We'll see how we represent normal forms as opposed to just syntactic representations of terms. We'll see how type checking dependent types work. So I'll show you the typing rules, and I'll show you how that corresponds to the code. And then we'll see the crucial part of where evaluation fits into type checking, which is the conversion check. So essentially, the high-level view of type checking dependent types is you'll synthesize a type for a term. You have a type that is expected. You check that both of those things evaluate to the same normal form. So a little bit more complicated than that. If you just do that, then it's potentially quite slow. By the way, that's what Idris 1 did. It's one of the reasons it was a little bit slow. But you'll see how that works in a more efficient way in Idris 2. And then finally, the thing that really takes something from being just an implementation of the type theory into something that is plausibly a programming language that the humans might want to program in, we'll add unification. So we'll see how to introduce implicit syntax, and we'll basically use all of what's come before. We'll use all of the kind of representations of normal forms. We'll do normalization where appropriate. We'll do all of the manipulations on terms as we go through unification. A lot of the time I'm just going to leave gaps in the code, so I'm not going to show you complete implementations. The complete implementation is available, so there's a kind of a reference. But I would highly encourage you to work through those implementations yourselves and check that you're able to do it. Right, so I'm going to show you, I'm going to show you a bit of type-driven development, as I like to call it. So, types first, and then we'll synthesize, we'll kind of derive a program from the type, or we'll refine a program from the type. And I'm not going to start at the beginning, because like I say, we had a ping of hands earlier, and I kind of got the impression that quite a lot of you know a bit about Idris already. So I'm just going to show you some of the things that are new in Idris 2, both to give you an impression of what we have to contend with when we're implementing it, but also to give you an idea of what's available while you're working on it. So one of the nice things about having implementing a language in itself is that, firstly, you get to use it, but also if you think a feature would be useful, you get to add it, and then you get to use it. So So we'll see how these features are important for working with Idris 2. So hopefully you can see some code now. Please somebody tell me if you can see some code, because I doubt my ability to use computers. Good, I'll take that as a yes, thank you. So what you see here is so I'm showing you quantities here, so quantitative types here. We're not gonna use linearity. So there are three quantities that we care about in Idris programs. There's 0, 1, and unrestricted. We're not going to use 1 beyond this introductory example, but we are certainly going to worry about 0. So we're certainly going to worry about things that are erased. So remember, every variable in an Idris 2 program has a quantity. It tells you how many times that variable is going to be used at runtime. So we're either going to use the variable 0 times, meaning that we can erase it, so it doesn't exist at runtime at all. We could use it exactly once, meaning that we can do some things with protocol design. It's that sort of out of the scope of this course, but thing you can do. And then there's unrestricted. So unrestricted is what you typically have. It's what you have in Idris 1. Everything is by default unrestricted use. And then Idris 1 did some compile time analysis to decide what to erase. Idris 2 does that in the types. So that turns out to be a really valuable thing, because it means we know what is available at runtime and what isn't. Like, we know how the compiler is going to behave. We don't have to guess how it's going to behave. We don't have to kind of prod it in the right direction to get to erase the things that we needed to. We just tell it. Anyway, so how quantities work is you can, in a type signature, you can put a quantity in the argument type. So here, so just a spoiler, we're not going to be able to write this function. So this is a function that says it will use x exactly once. X has type tie, so some polymorphic type, and its turn a pair of tie. So even though we're not going to be able to write it, I'm going to blunder on just to show you how this works in practice. So I'll make a candidate or a skeleton definition. We can look at holes. This is just like in Idris 1. So the interactive editing, if you've worked with Idris 1, then at least in theory, the interactive editing should work to some extent in Emacs and Atom. It definitely works in Vim. I'm using Vim here. I think it works to some extent in VS Code earlier as well. I heard Ohad says no. I would say right. That's an answer to a question. So I just saw the highlights of no. That's all. I guess it works to some extent in VS Code as well. So there might be, if there's any teething problems with that, we can figure them out on Slack. I'm using Vim because it's what I use. So if we check the type of a hole, we see, like in Idris 1, you would see the types of things, the names and the types of things. Idris 2 also gives you the quantity. So crucially, this tie has a 0 next to it, which means that we are not allowed to use that type at runtime. So it's not available at runtime. We can talk about it now. It's relevant to the type checking of the expression, but it's erased at runtime. And then the 1 next to the x means that x has to be used exactly once. So I can try writing this program. I can partially write it. We'll see that now we've consumed x. We're not allowed to use it again. So there's 0 x is available. Again, we can talk about it. It's relevant to the type checking, but it's not something we can use. So if I blunder on and try to use it, then it says, no, you can't do that. There's 2 uses of linear name x. So the important thing there is not so much the linearity, but the fact that we have quantities. We have things available at runtime and things that are only available at compile time. So as one very simple example of this would be the identity function. So if I try to write this function for all a to a, so writing my id here, I'm not allowed to inspect a. And it's a good thing that I'm not allowed to inspect a, given that this is the identity function, because if I was allowed to inspect a, if I tried doing something like, well, if it's an int, I'm actually going to increment it. That's not the identity function anymore, and it says, no, you can't do that. You can't match on the int because it's an erased argument. On the other hand, if I don't give a quantity, then it's assumed to be something that's available at runtime, and we don't have this arbitrary coincidental distinction between types and values. So the only distinction between types and values is that values are left of the colon, types are right of the colon. There is absolutely no reason why I shouldn't be allowed to inspect a type at runtime if that's a useful thing for my program. Yes, I don't get any of the properties of parametricity of that type, but I haven't said I want them. I haven't said that this not identity function. There's a clue. It's not going to be the identity function. I haven't said that this is parametric in the type, so it doesn't have to be. So I could try writing this now. I could write the same thing. But now if I say that A is an int, then it's fine to increment it. So people worry about parametricity at this point quite often. I'm going to say don't worry about it, because parametricity is not about being parametric in types. It's just coincidentally that it's always types in the interesting examples that you've probably seen. Parametricity is about parameters. It's not about types, as the name says. Things that are not types could also be parameters. So we could have something that is parametric in a nat, for example. I can't come up with a useful example of that off the top of my head. But anyway, that's the important distinction. It's about whether it's available at runtime or not. So myid, it's not available at runtime. Notid, it is available at runtime. So again, I spent some time on this because this is going to be crucial to us throughout when we're implementing Idris 2, because we are going to have some dependent types. So we're going to have terms depending on names in particular, and whether those names that we're depending on are available at runtime is something that we're going to have to think about. Right, we probably do want the names available at runtime because we want to display error messages, for example. But there might be cases where we don't need the names available at runtime, so we can explicitly make that distinction. Anyway, having quantities and types allows us to make that distinction between what's there at runtime and what isn't. Got another little example that illustrates that. This is my new favorite introductory dependently typed programming example because it captures so many of the interesting things that come up, particularly thinking about quantities and erasure in a very small number of lines of code. And it also illustrates something else I think which is important, which is when people start writing, when people start learning about dependent types, a common beginner, I'm not going to say mistake, I'm going to say a common beginner, what's the word, pattern maybe, is to try to put everything in the type. So try to have the type capture every possible property of the program. And what always happens is you end up running into trouble because you put things in the type that are really hard to explain as part of the program, and they're not really helping you anymore. So if you try expressing that sorting gives you an ordered permutation of the input, well, it's not tremendously useful in general to write a sort program that explicitly has that property verified. Like, you might be working in a context where it's absolutely vital that property is verified, but in general, it's not a property that you're interested in for working with the rest of your program. So the reason I say it's not a mistake is you learn an awful lot by trying to do that, but you don't necessarily achieve writing the program. So this example is run length encoding, and it shows how you can use one data type to describe the properties of another data type. So a run length encoding, if you're not familiar with it, is where you can compress lists where you have runs of the same element. So you say, so in this example, I have 3 X's followed by 4 Y's. So if you have a lot of runs of that form, you can compress that data. So it was used in painting programs certainly in the 90s when you've got large blocks of the same color, you can just say, oh, I have 200 pixels that are blue here. So this data type expresses the run length encoding of a list. Notice that it doesn't give the most precise description of a run length encoding of a list for two reasons. Firstly, I'm allowed to have runs of 0 things, which so repeating 0 x's. That's not tremendously useful. That's actually made the list bigger rather than smaller. And we might also this could also say we have 1x followed by 1x followed by 1x, which would be better represented as 3x. So it's not guaranteed to be the best possible encoding, but it is guaranteed to be an encoding. So we're looking for something that kind of expresses the meaning of the data without necessarily forcing us to think about what is the best possible representation of that data. So I haven't said what rep is. And I haven't actually defined rep, and I partly do this to show off a new thing that I've just added. So I'm having enormous fun with type-driven program synthesis. So if I ask it to generate a definition of this based on the type, then the first thing it's up with is actually the thing I was looking for. Slightly surprised by this, to be honest. But the reason it comes up with that one is that there is a heuristic that it will generate a number of candidate definitions, and then it will sort them according to uses of bound variables. And it happens that the first one it comes up with it tries to use every variable once, but not too many times more than once. And it just happens that the first implementation it comes up with is repeating the input n times. So I think that's pretty cool. Now, I'm not going to write the run length encoding function. In fact, here's one I made earlier, just to show that it's possible. I don't want to go through the details of this. Check it, type checks, good. But I will show you the decompress or the uncompress function, because that shows you erasure in the crucial way. So if I try, for example, I'll try generating there you go. What does it generate for uncompress? This is not the correct implementation of uncompress, because we've got n x's followed by y. It hasn't actually repeated the x n times. So this certainly type checks, but it doesn't know how to repeat the x n times. I haven't given it that search hint. So there is something that you might wonder about here. So I've got in the type the compressed thing is a run length encoded version of x's, and the thing I want to return is just x's. So the thing I give back has to be the same as the index of that data, so of that run length encoded data. So if you were writing this in Idris 1, you might be tempted to do something like call that comp rather than run length. You might be tempted to do something like this and just say, well, I already know what the list is. It's in the type, so I'll return it. So let's see if anyone's guessing what's going to happen here. So unfortunately, we can't do that. So we can't access x's, and it's something of a relief that we can't access the uncompressed data directly, because if we were carrying around the compressed data and the uncompressed data at the same time, we haven't really achieved anything. So we're just working with the compressed data, but all the time we've got the compressed data there hanging around, and we can make that just be completely clear about that. So you'll see here that the x's is something we can talk about, and crucially we can reason about it. This is going to be how we get out of this situation. So we can reason about it. We can guarantee that the risk of uncompressing the data is going to be whatever x's was. We just can't access x's directly. So this is, again, the reason I go through this. I'm going through this in such detail. You're going to encounter this quite a bit when you're working through the core representation in Idris 2. You're going to see things that are not available that you think either should be available or you need to reconstruct. So you need to think about, this gives you an additional thing to think about. Is the data something that you want at runtime or not? So there's a clue just above of how we're going to get out of this situation. I'll give you all of that. what we're going to return is the singleton. So a singleton is just a data type that has exactly one value, so the thing in the type. So X's is a thing we can talk about. It's a thing we can reason about, but it's not a thing we can have. But that does mean the fact that we can reason about it means that we can write a program that definitely produces the same as X's, but it's had to reconstruct it. And pleasingly, search will just give us the program that we expect. I heard a ping. That means someone's hand is up.
Yes, so my question is this a property of the definition of your run length data type, or is this a property of the type of uncompress? This property being that you can't cheat and return the uncompressed string because you don't want it to be stored.
So do you mean in this case specifically when I'm returning a list?
Yes.
Right, okay. So this is a property of the type theory. It's a property of the quantities.
Yeah, no, sure, but what I mean is that here in uncompress, in the type of the uncompressed function, I guess X is, well, it's a bit hard to see because it's just implicitly defined here. But if you write it out explicitly in the type signature, I assume you would put a zero quantity on it, right?
So yeah, like that. Yes.
Yes. So, but okay. But then, I guess my real question is that if this is something that's enforced by the type of uncompressed, that just kind of rubs me the wrong way, because I would want run length to be such that any time I have a run length at hand, I know that that's all I have and I don't carry the list around. So shouldn't that be something that is a property of the run length type definition?
Well, the run length type definition also doesn't. It's only in its index. It's not in its data. So the general rule is going to be that if you don't write it down, it's not in the program, and you haven't written it down at any point inside run length. So it's not there. But you always want to be able to say to express the relationship between bits of data, and there is nothing in run length here that forces other bits of data to have other quantities. It might be that it makes perfect sense in some setting for me to have the uncompressed data available at runtime. In fact, I have to, if I want to uncompress the data at all, I have to be able to have that uncompressed data somehow. So when I produce that singleton, so let's go back to the definition that we want. So if we were to say that this X's being an index of run length means that I am never allowed to have that X's, we're not going to be able to write this program because we're not going to be able to have access to annexes. So at some point when we produce our results, we might be wanting to use that uncompressed result in some other function. It might be related to the run length data. It might be that in fact we want to pass a zero quantity of that run length data to another function and have the uncompressed data. So we've got that flexibility. So if you the information you get about quantities and usage is going to be in a function type. It's not going to be in a data type. That's just how the theory works. I mean, there's all sorts of decisions that you could make about how you express the quantity. So do you put them on variables? Do you put them on the binders? Do you put them on the return type? Do you put them in all sorts of other places? The decision that I've taken is to do what Bob Atkey and Conor McBride did in a very clever quantitative type theory, because that way they worked it out and I didn't have to. So I would say that much like it to be, developing new type theories is not one of my strengths. So yeah, that's the important thing to remember is that if you have an implicit type parameter, then you can understand it as being a zero quantity of that type parameter. I had another ping.
Yeah, there's a question from the chat. Is there a reason why Idris doesn't allow the naming of constructors the same as the type, like in Haskell?
Yes, that's a great question, because it's kind of fundamental to how the type theory works, and it's something that we're going to come up against when we look at the representation of contexts. So the answer is they all live in the same namespace. So if you don't have this distinction between types and values as being in different worlds, then every name that you introduce is going to be part of the same world. So you have to pick a different name because they just live in the same world. It's, I guess, to some extent, once you've implemented a bit of a language, you start to see where some of these decisions that might initially look a bit weird and a bit annoying, you might start to see where they come from. It's got to the point now, for me, when I'm programming in Haskell, that I find it really odd when a constructor and a data type have the same name. I get a bit confused now when I see that. Anyway, we better move on, because otherwise we'll not get to the interesting bit. Well, I mean, I hope this is an interesting bit, but we'll not get to the most interesting bits. So I'd like to move on to talk a little bit about the structure of the Idris implementation and tiny Idris. There may well be lots more questions on this. I'm quite happy to take them offline. Like, I'll hang around a little bit after the lecture, and we can talk about them off the record if people are okay with that. Right. Ooh, not that window. That window. Now then, so now that you see some of the core features, so Erasure, how type-driven development works in the editor, we'll think a bit about how Idris 2 itself works. So just a bit of history. I started on this because I wanted to have a bigger system implemented in Idris, just to show that it would scale. And the only thing I really knew how to do was a new language. And at the same time, Idris was really starting to show, kind of creak around the edges. If you tried to do anything of any scale at all, it was really showing that it wasn't going to scale. So it needed some re-engineering. So just putting these things together, it seemed like a good time to try implementing Idris again. And why not try implementing it in Idris 1? Because then we'll at least make Idris 1 good enough to make Idris 2. So we'll say more about the kinds of ways that we're using types to make Idris 2 tomorrow and the rest of the week. So just a couple of things to mention. Firstly, the compiler is rather different in Idris 2. So if you've installed it, you'll notice that you need either Shea Scheme or Racket. So Idris 1 compiled via C in a C runtime that I wrote, because there was a point where I fancied myself as capable of writing a runtime system. It turns out, if you want good performance, it's much better to take a runtime system that has been worked on for decades by specialists. And people are often surprised that I've picked Shea Scheme. Shea Scheme is significantly faster than my hacky C runtime. If you turn off runtime checking, so this is why people are surprised, Scheme is a dynamically typed language. You can turn off all of the checks, all of the dynamic checks, or certainly the dynamic checks that are related to type checking, and you're getting quite a bit of performance, and as a result, it's running quite a lot faster. So the performance is kind of pleasingly. I sort of tested building the Idris 2 and Idris 1 versus building Idris 2 in itself. And it's actually more than an order of magnitude faster. It's more than 10 times faster. So it's no longer a problem if I need to change something in the guts of the system that everything depends on. I no longer have to go and make a coffee. So this has massively reduced my caffeine consumption. It's fantastic. So what's the structure? You'll see if you look at the code base of Idris 2, you'll see that it's divided into a kind of module hierarchy. So there's that gives you an idea of roughly what the phases are. So we've got the high-level syntax. That's all the high-level features like interfaces, implementations, the kind of where clauses, all of the things that you want to use to make programs sort of look nice, do notation, pattern matching binds, that sort of thing. Throughout, it's annotated with the source location, so that gives us half a chance of reporting error messages in the right way, so annotating the output of errors with where it actually came from. So that desuggers so the desuggering step doesn't really do anything clever. It really is taking the high-level syntax and turning it according to some relatively simple rules into an intermediate representation called TT-imp. So that's a type theory with implicit arguments. So that's still supporting some high-level features, but we've removed interfaces. So interfaces have been translated into records plus functions that look up things from those records or build records. So it's still got case blocks. All of the interactive editing support that you'll use in your editor or at the REPL, that's all done at the TT-imp level. So that means if you decide you want to write a new front end, and by the way, this would be a fun thing for someone to do. So if you're looking for a mini project, it could be quite fun to write new front ends to Idris that translate down to TT-imp. So people have fun writing back ends. I think there's no reason why people shouldn't have fun writing front ends too. So if you write a front end that translates down to TT-imp, then you get the interactive editing for that front end too. So just as an idea, if someone wants to go off and do that, I think that'll be rather fun. So TT-imp elaborates to QTT. That's a core type theory with quantities. So TT-imp elaborates, QTT is something that type checks. So in QTT, you only have data declarations and pattern matching definitions. That is it. So you can declare data constructors, you can declare type constructors, you can declare function types, and you can give pattern matching definitions for function types. And everything there is completely explicit. It is something that, in principle, you could write out in some machine-readable form. You could give to an independent type checker, and then you could have that independent type checker ensure that it's a well-typed Idris program. And if we're worrying about safety and correctness, it might be that you say, well, I don't completely trust Idris's elaborator, and I'm worried about, I want to make sure that this program really does prove the thing that I think it proves. You can write your own type checker. You can write an independent type checker that reads the Idris intermediate representation of the machine-readable form and says, yes, I agree that this is well done. So you could write your own external termination checker or coverage checker. That might be a worthwhile thing for someone to do. Again, if you're looking for a project, I think that would be valuable. So QTT, what we're going to see over the next couple of days is TT-imp and QTT. So we're not going to see the Idris 2 form, we are going to see TT-imp and QTT. Just for completeness, QTT compiles to a representation called CSEXP. This is an untyped lambda calculus, necessarily untyped because we've done the erasure step. So we've got rid of the erased arguments to functions. We've got rid of the erased arguments to data types. So they don't get generated for runtime code. Various transformations have happened. So inlining has happened. So inlining is especially important. So it's only via inlining that we can turn, like say, an I/O program into something that really is just doing the I/O operations. So in fact, the biggest, so this was initially in Idris 1, and probably the trickiest step, I spent a weekend porting the Idris 1 code to something that would work in Idris 2, and the biggest step was getting the inlining good enough that it actually compiled to something that ran at the same speed. Once you've done those, right, inlining is if you're interested in seeing how functional languages are compiled, you'll see that inlining is an unreasonably beneficial optimization. It has a huge effect. Question. Someone went ping.
Question in the chat. How feasible would it be to retain some in-block boldface types to make backend code gen easier?
Interesting question. I think the things you would need to retain would be primitives in particular. If you want to have unboxed primitives, that would be, I think, a very useful thing to have. Yeah, I don't know. Let's think about that. How feasible? On a scale of 1 to 10, let's call it 5. I don't know. A bit feasible. There's definitely things you can do. So some of the things that JC has to do with unboxed primitives, for example, I think we could repeat some of that. We could just take that work that people have done and apply it, and I think it would be highly beneficial. In fact, in the scheme backend, it's when I've tried micro benchmarks. So you can't read too much into this, but I've tried micro benchmarks comparing how the scheme runs against GHC. So GHC with strict annotations, and they're generally roughly the same. Sometimes scheme wins, or sometimes Idris with scheme wins. Sometimes GHC wins. But where you really notice GHC winning is when it is able to unbox primitives. So unboxing primitives could be, for certain kinds of things, could be a really valuable thing to do. Anyway, so the CX, the nice thing about CX being all it is an untyped lambda calculus, it pretty much directly maps to scheme. So Shea scheme is a default, but also rackets. There's a almost complete gambit scheme backend, but also a backend of your own design. So if you know how to compile a functional language of any form, you will be able to adapt that to working with Idris. So there are some other phases. So there is a lambda lifting phase. There's a translation to a normal form, but neither of those are used in Shea scheme. They're things that you could use on your own backend if that's the thing that you want to do. So that's the overall structure. Any part of the Idris system that you're interested in working on will pretty much fit inside one of these phases. But we can't really cover all of that, especially given that I've spent quite a while introducing what we're going to do using some Idris programming. We can't cover all of that. What we can cover is how are we doing for time? If I talk for 5 more minutes, is that okay? I know it's 4 o'clock. I'm hoping for an answer from Ohad, how long I can talk for.
It's okay.
I won't go more than 5 more minutes.
Yeah.
And if people do need to rush off now, then firstly I won't be offended, and secondly you won't miss very much. But I'll only talk for 5 more minutes. So Tiny Idris, this is a very cut down implementation of Idris 2. We're covering data definitions, function definitions. We've got a little bit of implicit syntax, so we can put underscores in for implicit arguments. While this is minimal, it still captures most of the difficulties that we need to deal with. So we're not worrying about sort of source location. So it doesn't have some of the things that would just be noise when trying to figure out how the system works. So it's just the essence of what it is to be a dependently typed language. Nevertheless, the structure of it is similar or the same as the real Idris 2. So if you can find your way around Tiny Idris, you will be able to find your way around Idris 2. It's just that Idris 2 is bigger. It's the same, but bigger. So the Tiny Idris source files, they mount directly to the Idris 2 equivalents. So just to show you what it looks like, what a Tiny Idris program looks like, and what we're going to achieve here. If you go to the SPLV the repo that I put the link in the slides and on the Slack, you'll find that you have this available. There's 2 versions. Version 1 doesn't have unification. Version 2 does. So version 1 is a bit simpler. They are complete, so I'm not expecting you to fill in the details before you can try it out, but I will give you some details to fill in separately. So it should build relatively quickly. It usually builds about twice as fast as this. It's just that the video is quite expensive. So there's quite a lot of source files here. And there's a bit missing that I didn't bother implementing. There's quite a lot of source files here, but to be honest, the majority of that is about parsing, and I've just copied that directly from Idris. So the things that you need to worry about are the ones that the core file, so anything core dot and anything ttimp dot. These are the only ones you need to worry about. There's about 3,500 lines of code, so hopefully you consider that sort of scale is going to be relatively manageable. And what Tiny Idris programs like. So here's a very small Tiny Idris program. There is a stage when you're developing a new functional dependently typed language. When you get to the stage that you can calculate 4, so when you can do plus suck 0 and get s of s of s of s of 0, then you're basically on your way. As soon as you can do that, you can do all the interesting things. So this bit, this data type definition, that is just Idris. That's just directly what you write in Idris. We have to be a bit more explicit. So this is something that Idris will work out for itself. So it'll work out that y is a variable and its type is nat. It will work out k. So we have to be explicit about the pattern variables. Otherwise, we write the definitions just like in Idris. I heard a question again. On the
if the person who asked raised their hand wants to, okay, that is fine. He asked, any thoughts on supporting conditionally support features depending on the backend? For example, shade.
Oh, is it about
float 32
this
bit?
is about the yeah, that's an interesting thought too. I've wondered a bit about how to manage that. Because different backends will always support different things. So the way it's currently working is that you can define an external primitive, and then a backend will compile it if it can and report an error if it can't. But that's not ideal. It would be nice to have a better way of managing that. So I don't know, but maybe you can come up with a way of managing that neatly. Okay, so Tiny Idris forces you to be explicit about the pattern variables that you're working with in a way that Idris doesn't, but we can scale up later to not have to worry about that. So a slightly bigger example, this was almost a vect-free talk, but I'm afraid we now finally have one. Vectors, by the way, people always complain about vectors in dependently typed programming talks. One great reason for using vectors is that everybody understands them. So it's a good first example because you kind of know what's going on inside. This is where you start to see why it's really important to deal with unification. So we have to be. So although we have implicit syntax, we can leave gaps for arguments that we're not going to fill in. We do still have to we'd have to like fully give the type. So nil has this additional argument of its type parameter, and cons has its type and the length of the tail. And then we can write an append function. Again, we have to be explicit about the types of the pattern variables. It's a little bit annoying, but we can leave implicit the arguments to when we call a function. So this is when we get to unification, we'll see how this implicit syntax works. Otherwise, we're going to have to give the applications in full. So we've got a couple of tests here, just to see how that works. So if you're in this test directory, you can get at the build version, and all you can do inside this. So don't expect this sort of nice feature. We can type in expressions, and it will tell us. It will check it. It will tell us what its type is. Tell us what its evaluation is. So let's do 2 plus 2, and good. So this is the check result. This is the type and the evaluation. If we look at, let's do cons. So let's do. I've defined this data type test with these constructors A, B, C, D. So I can say cons A onto nil. And you'll see that when it type checks that, so this is a hint for what's coming later, these things here, these are meta variables standing for the result of type checking. So these will have solutions. What we don't do is substitute in the solutions when we do type checking. We only substitute in the solutions when we evaluate it. So this is part of what we need to do to make the performance any good. So then it will evaluate that, and you'll see in full what the result of evaluating it is. And finally, let's just try appending the two vectors, and you'll see in full what the result of appending those two vectors is. So it's that looks weird. Something doesn't look right there. I'll come back to that. All right. No, it's not printed something. I might have to debug something. Anyway, yeah. So that's Tiny Idris. So modulo that thing that's just confused me, which I'll figure out later. That's what we're going to be working with. I hope that's not a bug in the type checker. That would be embarrassing. So that's what we're going to be working with. That's what we're going to be working towards implementing over the next couple of days. So I think that's a good point to stop for today. So we're going to really dive into the code of Tiny Idris tomorrow. What I'd suggest you do as exercises in the meantime is just take a look over the code, browse through what each of these modules are doing. So if you know a little bit about what the terms of a type theory are, you'll be able to see inside core.tt, you'll be able to see a mapping from those terms to their representation. I'll work through that in more detail tomorrow. And don't worry too much about what's going on. Don't expect to understand it yet. Just try to get a picture of how the overall structure of the system works. Particularly, the particularly important bits, like the top level bits. We've got this process decl module that works through the top level declarations and adds them to the global context. In the process, it has to elaborate the TT-imp terms into the type checked TT terms. So, and otherwise, we've got a couple of warm-up exercises just to check that you're up to speed with Idris programming, up to speed with reasoning about associativity of list append, for example. That's something that we've had to do quite a bit inside the core of Idris. So take a look at those exercises. I'm quite happy to answer questions about that. Probably on the Slack is a good place to ask between now and tomorrow. Otherwise, I will stop there, and if anyone wants to kind of chat informally for a bit, I'm happy to do so now. So, thank you very much for your attention.